Hello friends, welcome back. I'm Kaushal Kumar. Today we will walk through regression machine learning topic. Regression is a machine learning concept. It is a fundamental concept in the machine learning which comes under supervised machine learning, where you predict the values for continuous numerical data. I will give you the detailed framework how regression will work and how you can continue working with the regression. So don't be confused. I will not explain any mathematical concepts or any statistical theorem to you today. My target is to explain regression, how it's fit for you, where you can start building your understanding in the regression model. Let's have a look together. What is regression exactly? Think of regression as a function approximation problem. You are a developer, you already built several functions in your program, but the functions, whatever you are writing in your program, you always know the output. Output is known by you, and then you write a logic, and based on that logic, you receive the values from the user, or the function will ask the input parameters, and then uh, your logic would be inbuilt in the function, and then you return the output. But this is already known, so it's a pretty simple in a traditional development. But what if you don't know the output, you have only data and you have a demand for predictions. Let's say if the logic is deterministic, you write the function manually, that's fine. But here you don't know the inside logic. If the logic depends on the patterns in the data instead of rules. In a traditional development, what exactly is, you know the rules. So you write your rules inside the function, and then it's return the data or returns the output. But here you train a regression model to approximate that function. So this is the beauty of machine learning, where you don't write the fixed rules, but our model will itself learn from the data which we provide, or the data on which we train our model itself, it's learned from that. So let's walk through in more detail about the regression, how it is fulfill the demand, where you can start, how do you deploy your model, how do you predict the values, how do you monitor and the model, and how if the model giving a wrong values, then how you can correct it. So regression predicts a continuous numeric value based on the patterns in the data. Example of the regression, this will definitely gives you a boost up where you can build your understanding, from where you can start building a regression model. So if you heard regression, somebody's telling you, oh, I'm explaining regression, so it's out of your head. But don't be confused, it is very simple and powerful tool wherever you have demand for predicting values based on the numerical data or continuous data. What you can do, predicting processing time based on the payload size. Have you think you developed your API, and then you provided the payload, or the payload will be sent to the endpoint, and then you process the payload and return the output. But if someone asks you, or if we need to present that prediction time, okay, what would be the payload size, and how much time our API will take. This is the prediction for processing time that you can easily achieve through regression. Predicting server load, it's again interesting topic. When we buy a infrastructure, management always asks what could be the server configuration. and whatever the configuration you are demanding, what are the basis for that configuration. Predicting defect rate. This is again a very interesting topic in the software development or in the industry. Let's say if you develop a software for manufacturing industry, it is demanded with us what could be the defect rate based on manufacturing pipeline. These are the some examples I given to you where you can build your understanding where regression exactly fit. Now we will talk to model integration and system design where model live in real system. This could be a question for a new person who started or who just started career in the machine learning. So think as your normal traditional application where you deployed your model, where you deployed your application. It is quite similar for machine learning model as well. Let's say you have a data store. The data store could be your file systems. The data store could be your relational database, or it could be non-relational database. It, it can be in a several format. And then you train the pipeline. You have trained model. The pipeline comes first because when you have a data, you collect the data and then you build the pipeline for your data and train the model so that model exists now, and then you write APIs. Through API you are connecting your model, and at last stage the client app means any application which consumes your API. So whenever the request goes to your from your client app, it goes to your prediction API, it calls the models, and the model will give you the prediction based on what, the based on the trained data which earlier you used for your model. Now the question comes data validation and feature engineering. This is crucial step in supervised machine learning models, especially I'm talking about now in this session, I'm talking about supervised machine learning where we are in regression. So data validation and feature engineering is a crucial step in our model training. Data validation. What is data validation? That's the bigger question. And here, generally, the machine learning developers are confused, or who is starting their career in the machine learning, they confuse what is data validation. I'll explain you in a very simple terms so you will understand what is data validation. Think as a unit test. You write a program and you write a unit test where you validate whether your program is giving the right output or not based on the predicted input or based on the several inputs which you provided to your unit test. So data validation is similar. You are validating, are there any missing value exist in your data, are types consistent, means it could not be, let's say, some of the string data or some of the numerical data and some of the junk data you do have in your collection. Are the range are realistic, because the range also play an important role. If you have a numeric value, it should not be some values in the 0 to 10 or some values in a million and billion. So the range should be realistic as well. Any anomalies or outliers, this you will ensure in your data validation part. I already recorded my earlier videos for data validation. You can refer those videos. I will put the link in a summary. Feature engineering is comes together with the data validation. It's all about parameters. If you have bad parameters, your output would be bad. This means your model will generate the bad output. If you have a good parameters, excellent predictions will be given by the model. Now the next topic, deployment patterns. How, when, where you deploy the model. There are several patterns in the model deployment. First is in-app deployment. This is local. It's always faster. As an example, you are running your project in Visual Studio. You have several libraries, and parallelly, if you start your library, then it is always too fast. There is no lag. So this model packed as ONNX or ML.NET artifacts. As I mentioned, definitely there is no network loop. It's on the local system. It would be fast. Where we can use this model deployment patterns, you can pack your model in a package for IoT devices that always would be higher, or desktop application where you don't need to communicate to the cloud infra, so you can use this in-app deployment. Think as in a desktop application or console application which you built and that used by IoTs, or that if it's used by any hardware. The next pattern is model as service. As you already know, software as service, SaaS. So this is model as service. You expose your model, your API endpoints for the predictions. So any language can consume, any client can consume your model. It's easier to update model without redeploying entire application. While if you opt the in-app deployment, then whole application you need to deploy. But here the changes are not non-breaking changes. You can deploy your model easily. Another one is batch prediction. This is one of the type of deployment patterns where batch predictions are used in the industry. You can assume, let's say there are several jobs which you run on the daily, nightly, or at a periodically. Yeah, those jobs are running. So you can deploy your model where these things, the periodic jobs would be run. This generally used to fetch the data for dashboards or downstream systems. It is popular in the finance, retail, and manufacturing industry where you deal with the predicted data, which was already predicted and generated and stored, sent to a data store which you can utilize. There is another deployment pattern, real-time streaming. The model is a part of event stream, Kafka, Azure, Event Grade, Hub, Spark, many more, and it's predict the data flow as it receives. The next topic comes monitoring and troubleshooting. Guys, why I'm explaining these concepts to you? It is you should have clear understanding. You are already experienced developer. You know how to develop application, how to deploy it, and then how to monitor, how to keep monitoring on the production system. Similarly, it is applicable for machine learning model as well. So till now we learn what is model, what is regression, how we build regression model, how to perform the feature engineering and data validation, what deployment method we use for our model, and now the topic is monitoring and troubleshooting. This is pretty important, and really it's important because when you deploy your model on the production, then you have to keep monitoring and troubleshooting. But here is a one catch. Think as your traditional application or your service. If your service goes down, then you will trigger or you realize your service is down. But for the machine learning model, it's slightly different. Model fails silently unless monitored. What does it means? What to monitor? How do you know your models need monitoring? Input drift. Are coming values very different from training data? This means what? This means you need to train your model, you need to optimize your model time to time. It doesn't mean, let's say, if you have bunch of data and you train your model on your data and then it will run as long as, yeah. So time to time you need to optimize your model or retrain your model based on the new data which you receive. In this era, you have to ensure that the incoming values from different training data must be accurate. Here we need data validation. Prediction drift. The model giving you the prediction, is it shifting unexpectedly, or the values which is predicting is not in the range of the model in earlier stage which we deployed? This you need continuously monitoring. And the feature health, missing values, null, zero, spikes, this definitely you need. It's a part of data validation, and time to time you have to train your model or you have to optimize your model. Troubleshooting approach. How do you troubleshoot, or how do you know your model is down and you need to troubleshoot it? You need to find the root cause. If the model accuracy drops suddenly, then definitely it's triggered to you. Figure it out. What is the root cause? If prediction seems inconsistent, for example, you develop a model of for house price predictions, and with some duration it gives you the right data, but suddenly it start giving you the random values for house prediction. Then you can, it's a trigger point for you. Then you have to troubleshoot what's went wrong, and if your model processing is quite slow. Now, interesting topics for you. You heard a lot from me. Regression model, develop this, develop that. But why we develop? What is the real use case in the industry which insists you to develop regression machine learning model? If you have demand predicting performance, as I mentioned in my last example, server load, compute time, job completion time, this you need to ensure or you need to predict. The regression is best tool for you. Price recommendation system, predict discount amount or ranking score. This could be another example. If you have these demands, then regression best fit for you, because these all deal with continuous numeric data. Engineering and manufacturing industry, predicting defects, energy uses, production, throughput. In the manufacturing industry, one is hot running topic, ensuring the machine health. This is important thing, because if on time or before time you are able to predict your machine health, or you predicting any damage which could be in the future, then regression is the best tool for you. You can do this in your some set of rules, but if you want to predict the machine health based on the data which you have or which you collected in past, then regression model is the best fit for you. Resource planning, where you have future demand, inventory shortage or capacity requirement, then regression is the best tool for you. As an example, if you are in the HR company or in HR department and you are open recruitment, and for the recruitment you have some opens for some positions, and you decided a budget and the range of the budget. But this budget is, what is the basis of this budget? Do you know? Or you define it randomly? What are the basis for this? If you want that whatever the position we are opening in our company, first we need to analyze what salary range shall we offer to the new candidate based on my existing resources. Then regression comes here in the picture. You need to collect the data for your existing resources in the company based on their number of experience, their expertise, and their the technologies they use. And when you put this data to the model and you ask, hey, I have thousands of employees in my company, and these are the different skill sets of those employees and the expertise area of this, and this is the experience, and I want to hire a new resource, and this the parameter of the new resource. Let's say I want to hire a developer for the 5 years or 10 years of experience with the expertise in the machine learning or the expertise in the C sharp or any other technology. What could be average budget based on our existing resources in the company? Then regression model will gives you the data. This will definitely helps in the recruitment industry. Thank you very much. I hope these are useful topic for you, and in the next session I will explain the practical concept of the regression. In next session I will explain you how you will build a machine learning model or machine learning with regression. So in the next section, please, if you are interested, you can continue watching my next series, or this series I will explain one by one topic in detail. Thank you guys. Thank you again.